Welcome to The Explainer. Today, we're diving into machine learning. It's that silent engine humming behind your favorite apps. And honestly, it's a technology that's reshaping our entire world, sometimes in ways you don't even see.
So, how does your streaming service know exactly what movie you'll want to watch next? I mean, it's kind of eerie, right? That ability to predict what you'll like, whether it's a new song, a movie, or something to buy, well, that's machine learning at work, right in your day-to-day life. But how does it actually do that? Okay, so here's what we're going to cover. First up, what even is machine learning? Then, we'll get into how machines actually learn. After that, we'll look at where you can see it in the real world. And finally, we'll dig into some of the really tough challenges and ethical questions.
All right, let's jump right in. So, what exactly is machine learning? At its heart, ML is this really cool part of artificial intelligence. And the best way to think about it is this. Normally, a programmer writes super specific, step-by-step rules for a computer to follow. But with ML, you kind of flip that. You give the computer the data and the goal, and you let it figure out the rules on its own.
So, the big idea here is that instead of programming a computer with explicit instructions for every single possibility, we just feed it a ton of data. And from that data, it uses some pretty clever statistical algorithms to spot patterns and, make predictions. It's all about teaching it to learn from experience, not just follow a rigid script.
Now, this quote from Tom Mitchell might look a little academic, but it really gets to the heart of it. Let's just break it down real quick. The experience, E, that's just the data we feed it, like a million photos of cats. The task, T, that's what we want it to do, say, identify which photos have cats in them. And the performance measure, P, that's just checking how often it gets it right. So the better it gets at the task, the more it has learned. Simple as that. It's learning by doing.
And this whole idea isn't brand new. The name machine learning was actually coined all the way back in 1959. But things really started to heat up later. In the 80s, there was this breakthrough called backpropagation, which is basically just a fancy way of saying the computer could learn from its mistakes. That was a huge deal. And then, fast forward to 2016, and you get this incredible moment where AlphaGo, an AI, beats one of the best human players at the game of Go, which, by the way, is way more complex than chess. That just showed the world what was possible.
So, okay, how does this learning stuff actually happen? Well, it's not magic. It really boils down to three main ways or paradigms. Let's get into them.
This table breaks it down perfectly. First, you've got supervised learning. Think of it like studying with flashcards. The data's all labeled, this is a cat, this is a dog, so the machine learns to connect the dots. Then there's unsupervised learning. Here, the data's just a big jumble with no labels. The machine's job is to find patterns all by itself, kind of like if you dumped a giant bag of mixed-up toys on the floor and had to sort them into groups. And finally, reinforcement learning. This is all about trial and error. The machine tries something, and if it's a good move, it gets a reward, a treat, basically. Over time, it learns to maximize those rewards, just like training a puppy.
Okay, so we've covered the how, now for the where. And the answer to that is, well, pretty much everywhere you look. This stuff isn't just in research labs anymore, it's woven into the very fabric of our daily lives.
I mean, just think about it. When you talk to your phone's voice assistant, that's ML. When your email magically knows what's junk mail, ML again. Those movie recommendations, the fraud alert from your bank, the ads that seem to read your mind, it's all powered by machine learning. And it's not just the little things, it's driving huge advances in fields like medical diagnosis and even self-driving vehicles.
But of course, with all this incredible power comes some really serious challenges. There are major ethical questions we have to ask, because when we build these machines, we're not just dealing with code, we're dealing with some very human problems that get baked right into the system.
So one of the biggest headaches is something called the black box problem. Basically, these systems can get so complicated that even the people who design them can't tell you exactly why it made a particular decision. It just works. And that's a huge issue, right? I mean, how can we truly trust an AI to make life or death decisions, like in medicine or law, if we can't understand its reasoning?
And that leads to another massive problem, bias. Here's the thing you absolutely have to remember. An AI is only as good or as fair as the data you train it on. Garbage in, garbage out. Or in this case, bias in, bias out. And this isn't just some abstract idea. It has caused real-world harm. Way back in the 80s, a medical school's computer program was literally rejecting applicants just because they were women or had names that didn't sound European. And even today, we see things like predictive policing algorithms that end up unfairly targeting minority neighborhoods simply because they learned from historical data that was already biased.
So it all leaves us with this one big, kind of unsettling question. When we find bias in our AI, is it a bug in the machine? Or is it just a mirror reflecting the biases that are already all around us in our own society? As we teach these machines more and more about our world, you have to wonder, what are we really teaching them about ourselves?